Hello, I'm Hein, and today I'm gonna talk about optical devices. Before we start to see today's topic, we have to review that we learned at the Fundamental Semiconductor Devices 1. Mm, as you learned before, when the electron absorbs some energy like light, the electron in the lower energy level goes up to the high energy level. But because of the Boltzmann distribution, the probability of the extents of electron is lower in high energy level than the low energy level, so the electron can't stay longer in the high energy level, so the electron goes back in the low in energy level. In this process, the electron have to emit the energy that it's absorbed when they go up. For instance, the electron emits the energy as a form of light. So we can call it as a light emissions. Mm, with the when the light was when we light the semiconductors, or for example PN junctions, the light can't absorb fully into the device. For example, some lights are reflected in the surface of the device, so we can calculate the flux which flux in the surface of the semiconductors with the reflection coefficient and transmission coefficient. In the position where as the flux is 37%, we call the alpha in there as a I'm sorry, I can't remember it exactly, but uh, but anyway, when the alpha is high, we can say it the device absorbs the flux well. So we can draw the graph like this. When we make photo detectors, we can draw the photo detector works at the depletion region, because so when the depletion width is big, the current is flows more than when the depletion width is smaller. So we can run this bias at the situation under situation like reverse bias. And when we make a photo detector, we can find a open circuit voltage and short circuit current within the IV curve. So we can draw this curve like this. The blue line is the solar cell's IV curve, and the black line is the load line slope. So we can get the point which the two lines encounter, and with this we can calculate the fill factor. The maximum power is the production of the VOC and ISC, but we can reach at this maximum power. So the real power which is the production of the VM and IM, which is encounters with the load line slope is the rear power, and we can calculate the field vector with these two powers, the I VM IM over VOC ISC. And next we can see the next we have to know about the diffusion length, because we have seen in the before, diffusion length is very important factor which control the short circuit current. So we have to make long diffusion lengths to make the good photo detectors. And next we will see the LED. LED is the light emissions device, and it is made because of the recombination in the depletion region. So when we apply the forward bias in the PN junction, the electron moves to other side and the holes to move to the other side. So when they pass in the depletion region, the electrons and holes recombination at that position. To make a good LED, we have to make them stay more longer time at the depletion region. So we can make a device like this. If we make a quantum well in the depletion region, the electrons which moves to other sides have to trapped in this, and the holes are trapped in this area too. So we can make more longer time to stay, the carriers can stay in the depletion region, and it means it is more easier to that carriers recombination, and it leads to we can make a good light emission device. Okay, today we talked about optical devices in simply, and thank you for listening my review.